Very good afternoon, ladies and gentlemen, and welcome to the Young Community Physicians Forum webinar series organized by the Academic Subcommittee of the College of the Community Physicians of Sri Lanka. So, drawing your attention initially to a few ground rules. First, please keep mics muted and your video switched off for minimal disturbance during the webinar, and make sure that you fill in the Google form at the end of the webinar so that you can receive the e-certificate. So now it's with great pleasure that we welcome Dr. Dulani Samaranayake to today's webinar. So Dr. Samaranayake is a distinguished academic and a senior lecturer at the Faculty of Medicine, University of Colombo. And with strong foundation in community medicine, she holds MBBS, Masters, and MD, and brings over 2 decades of experience in teaching, research, and public health practice. So her contributions to medical education and research, particularly in the areas such as health systems, behavior risk factors, and medical statistics, are very widely recognized. So today we are very privileged to have her here leading this very insightful lecture on the practical application of principal component analysis and confirmatory factor analysis, which is a topic of immense relevance to research and public health professionals alike. So we know that her expertise in applying these statistical methods real world in health research will undoubtedly enrich our understanding and inspire the practical applications in our work. So let us warmly welcome Dr. Dulani Samaranayake. Over to you, madam.
Thank you, Dr. Tatsara. And I would like to thank the academic subcommittee of the College of Community Physicians for this opportunity. And I'm very pleased to share a few of my ideas with you all on factor analysis. So we had given you a Google form where we wanted to collect the questions like things, the areas where the audience wanted clarifications on. So based on the questions we received, I have sort of made a small presentation where I have tried to address those questions and give answers as much as possible. So let's first look at those. And then we will take up any other questions that you would be having. So, so moving on. I will not go into the basics of factor analysis, either exploratory or confirmatory. Assume that you have had inputs on basics. Right? So we will just look at the different. So the very first question or thing that we would like to clarify is factor analysis needed? So why I selected this question is increasingly we see lots of research where factor analysis is considered as the ultimate solution to all validation problems. So that is not so. Factor analysis is a technique which is suitable for certain situations. So first thing is we have to decide whether factor analysis is actually suitable or needed for our research study. So factor analysis would be applicable in situations where we have underlying latent variables which are measured by certain observed variables. For example, let's say quality of life is not an observable variable, but we know that this construct, this idea is there. So it is a sort of a latent thing, but this is indicated by various aspects related to our physical health, mental health, likewise. So these observable variables are likely to be influenced by this latent variable. So factor analysis is very suitable for situations like this, where we have observable variables and these hidden latent variables underneath. But if your study instrument is purely based on directly measured variables, where latency is not a situation, then do not think of factor analysis. You will have other methods of validation. So, for example, the situations where this would be applicable would be where you are all together developing a new instrument. So, in this new instrument, probably an instrument related to psychometrics, where this latency is there. And you want to identify what are the underlying constructs of dimensions in this instrument. Or in situations where these latent variables exist as a method of construct validation. Also in instrument development as a method of reducing the items. If you have a large number of items which you want to reduce, again, factor analysis or mainly principal component analysis would be applicable. So these are some of the situations where we would go for factor analysis, but also be mindful that there are situations where we don't really need it. So think carefully before we decide on factor analysis. It is not the only way to establish construct validity. Then, just to put you in the context, this is an example. A new study instrument is developed to assess COVID-19 related anxiety. Initial instrument contains 32 items, and then principal component analysis identifies 3 underlying latent variables. So this anxiety, the underlying reasons for anxiety are the 3 latent variables: fear of death, stigma, and disruption of protein. And then these 3 latent factors explained 78% of the variability in this data. And certain items were reduced and the instrument was finalized. So this is a classic example where this latency exists and where factor analysis is going to be a useful technique. So types of factor analysis, just to recapture: exploratory and confirmatory. So exploratory factor analysis, there are different types. Principal component analysis, in some literature, you don't consider it as a proper form of factor analysis, right? But in practice, we see principal component analysis used largely as an exploratory method. So, but common factor analysis is the true form of exploratory factor analysis. So there was actually a question asked by one of you all. Where would these be applicable? Where would we use principal component analysis or other forms of exploratory factor analysis? Right? So principal component analysis is largely a mathematical technique. Therefore, according to the literature, it is not a very good method of identifying the latent variables. It is much better for data reduction and reducing the dimensionality of data rather than identifying latent variables. So if your main aim is to capture the latent variables, common factor analysis is a better option. So this is according to the literature. But in practice, what we have seen is that when you try out both methods in the data, usually you get similar answers most of the time. So PCA and common factor analysis performed in the same data tend to give similar answers. So PCA also is good enough in most of the situations. So confirmatory factor analysis is when you have a prior factor structure we try to confirm it using CFA. So this is just to recapture. Exploratory is we explore, so we allow all items to load onto any of the latent variables. But in confirmatory factor analysis, we have a factor structure in mind and we try to see whether it is fitting the data or not. So I hope the difference is clear. Then comes the question, do we have to do exploratory factor analysis or confirmatory factor analysis or both? That is also a common question that comes to most of the researchers. So there are instances where we would go for both. That is, if we are developing a very new psychometric tool, starting from scratch, by developing items, trying to identify the factor structure, right? So if a new tool is developed, then exploratory methods are required for the scale development process. Scale development process is where we identify our scale structure or factor structure. Then we have to evaluate or confirm the factor structure using confirmatory factor analysis. So once these two steps are done, your tool development is very much complete, like, right? So if developing a new tool, you would go for both. But if you are validating an existing psychometric tool which already has an accepted factor structure, which has been shown in other studies, then you don't really need to explore the structure again because the structure is already known. So then we would go for confirmatory factor analysis only because what we want to do is to confirm that this factor structure is there in our population also. But remember, during the tool adaptation process, if the tool changed a lot, then you might consider doing exploratory as well. So that is a decision that the researcher has to make depending on what happened to the tool during the adaptation process. So exploratory CFA, there are specific situations where we use, and also both are used mainly during new tool development. Then the other question is, in my data, is factor analysis possible? So there were questions related to this also. What are the requirements? What are the data requirements for factor analysis? So basically the question we have is, can I do factor analysis in this data? This is a common question that we encounter. So there are certain requirements in our data that needs to be fulfilled if we have to go for factor analysis. First is sample size. So sample size, we go by the general rule, at least 5 to 10 participants per item or per variable. Right? But having said that, most of the literature suggests that there should be at least 200 participants in the data, in the sample. So if the instrument that you are using is a small one, where 5 times of data would be less than 200 participants, then it is best to go for maybe 10 times, 8 times of the participants per variable and make sure that you are close to 200. So that is about the sample size. Of course, there is no other formula for sample size calculation for factor analysis. But having said that, remember, if you are doing a validation study, and if factor analysis is only one form of validity that you are trying to establish, then you are trying out other methods of validity also, maybe comparing with other constructs and trying to assess convergent validity, or you're going to assess criterion validity, Then remember the sample size calculation for those should apply here as well. So for factor analysis per se, we go by 5 to 10 items. Then the data type, that is what type should the variables be. It could be numeric variables, continuous, or it could be even ordinal variables, right? But if you are using ordinal variables like Likert scales, you have to substitute them with numbers, right? So there should be numbers in the data. Nominal data, it is not possible to do factor analysis. Dichotomous data in the form of 1 and 0, again, factor analysis is not going to work on these simply because it is not possible to get a good correlation matrix with data that is dichotomous, right? So therefore, for dichotomous data also, factor analysis will not work well. So that is about the type of variables. Then we also need to have linearity between the items. There should be linear relationships, right? So if there are lots of items in the study instrument, it might not be possible to look at all the scatter plots, but go through a random sample of scatter plots and see whether there is some linearity in the data. Not perfect linearity, obviously, but some linearity should be there. Then correlations between variables. So this is also an important thing that we need to check before we go into factor analysis. There should be a certain level of correlation between the items in order to do a successful factor analysis. So basically, if there is a correlation of about 0.3 between most variables, that is a very good correlation matrix for factor analysis. But let's say there are variables which don't correlate with the other variables at all, or the correlations are very low. Then such variables, items might not do well in the factor analysis. You might even consider removing such variables. So going through the Pearson's correlation matrix carefully, seeing that there are weak or close to moderate level correlations between the variables is a very important step before we go into factor analysis. On the other hand, there should not be high correlations between the variables, which we indicate by multicollinearity. So multicollinearity is there are very high correlations between variables, which should not be there. So you have to, in the correlation matrix, we need to check for that as well and make sure that there are no high correlations like 0.9, 0.95 between two variables. If such correlations are there, what does that indicate? It indicates that both these variables are assessing a very similar thing. So actually, both of them need not be there in the data set. We don't need both of the variables in the data set. We can do with one of them. So we can select one variable and leave out the other. So correlations, multicollinearity can be determined by going through the correlation matrix and looking for high correlations. Also, you can run regression using the items and look for this variance inflation factor. Right? So variance inflation factor should be less than 10. Then another is the factorability of data. So these are actually included in the principal component analysis and exploratory factor analysis process. There are two tests called the KMO test and the Bartlett's test of sphericity. The KMO test assesses the adequacy of sampling, sample size, and it should be close to 1. So usually a KMO value less than 0.6, 0.7 is acceptable. Bartlett's test with it assesses whether the correlation matrix is factorable. So Bartlett's test should be significant in order to consider that the data is factorable. And also there should not be outliers in the data set. So therefore, all the items need to be tested using box plots to see whether there are significant outliers, and extreme outliers need to be removed. So these are the very important steps. And if these are violated, factor analysis cannot be performed. So these assumptions we need to fulfill before we move on to factor analysis. So this is just a correlation matrix. KMO and Bartlett's test result, right? KMO test 0.8 means it is quite satisfactory. Bartlett's test significant means again the data is factorable. Then we will look at some of the questions related to principal component analysis itself, right? There were few questions. One question is how many components to retain, right? So once we conduct principal component analysis, the question the researcher has is how many components should we extract from the principal component analysis. Actually, there are several methods to decide this, and it is up to the researcher, because if you are developing a new tool, it is your study instrument that you are developing. And based on reasoning, scientific reasoning, you should be able to decide what method to follow. The common methods that we use are considering the total variance explained by the components, and also based on the eigenvalues and based on the scree plot. These are three of the very common methods that we use. So the total variance explained means out of the components that are created in the principal component analysis, at least 70% of the variance is explained by a particular number of components. We can extract those components for the study. And then eigenvalues, we go by the cutoff of 1. So all components which have an eigenvalue more than 1, we can use them as the components in our tool. And then we also have the scree plot, right? So this is the total variance explained table. So based on the table, we can select looking at the cumulative variance, right? Cumulative percentage variance, we can decide at least 60% of the variance is explained, those components to be extracted. Then the scree plot. The scree plot is a diagram where we plot the eigenvalues against the component number. And then we look at how these eigenvalues have changed, and we identify this point which we call the elbow, where the eigenvalues sort of flatten off, right? So when the eigenvalues flatten, that means the variability explained by those components are not really changing. It's a very small difference. So these components are not very important for our data to explain the variance. So we have to select where the scree plot is just bending. So in this example, it would be some place where the scree plot is just bending like about 5 components. So this is also one way that we can use. So different methods, right? It's up to the investigator to decide which method you would apply. Right? So eigenvalues more than 1 is a very commonly used method, but it can result in retaining very not very important components also in our data set, because sometimes we end up having a large number of components, and some of these components are actually not very useful. They may have 1 or 2 items and they do not really contribute to the instrument that much. So using eigenvalues is not a must. Like, we can decide not to go by that criteria also, based on the requirement of the researcher. So that is about how many components we need to retain in the principal component analysis. And then another very common question is, when double loading items happen, how can we address that? Now, once we have done the principal component analysis, we look at our component matrix. That is, how each item is correlated with the component. So we call this loading, right? That item is loading onto the components. So if a particular item is strongly loading onto a component, then all is well. We know this item is related to this component, and that is what we really want. But then there are the troublesome items which will not load into any component strongly. We see that with one component, it has a loading of about 0.35. Then with another component, about 0.38, right? So it is not really relating to any of the component strongly. Or sometimes there are items which have a loading of maybe 0.45 or 0.5 with 2 components. Then we are not very sure whether to put it in which component should we include this. So this double loading and not strongly loading onto any component is a common problem that we encounter when we do a principal component analysis. So if you get this type of items in the principal component analysis in your matrix, so the best thing would be to delete such items, right? Because these items also do not support the factor structure well. So when you decide to delete or remove an item, it is important to look at the communality of that item also. Communality is the amount of variability of the item that is explained by the components we identified. So if the communality is low, that means this item does not really fit with these components that we identified. So the item that has poor loading as well as low communality, that is a good candidate to be removed from the study instrument. So in principal component analysis, do not hesitate to remove such items. You don't need to really retain all the items somehow and put it into a factor structure, because principal component analysis is largely a technique which helps in data reduction. So if you get items which do not load onto a component well, so be little bit, lavish about removing such items from the data set, because your study instrument will finally be much better without such items than with them. But remember, when you generate items, keep this in mind when you generate, and the number of items that you put into the principal component analysis. Always it is good to have a little bit more than what you really aim to have at the end. So if you are aiming for a 25 item study instrument, have about 30-35 items in the initial questionnaire, so that even the ones that get deleted, you can delete them without any hesitation and keep the ones that are only loading strongly onto the components. So that is about double loading or items which are not loading anywhere. Then another question that comes to researchers is how to name these components. So sometimes we start principal component analysis with a very open mind. We have a set of items undergoing principal component analysis, and then we want to now have identified a component. How do we name this? So this becomes a problem when the items that are there does not fit into what we already know about the this particular subject or this particular instrument. So the important thing at this step is to keep an open mind. So be open and go through the items very carefully and try to see what is the common underlying factor in all these items. So there is something common. That is why the study population has sort of answered these questions in a similar way. So there is something similar, some underlying thing which is common to all these items. So our naming, the trick is to identify that particular latent thing that is underneath the component. So sometimes a problem that may arise is that certain components seem to be divided into two, right? So now let's say we have a tool where physical health is a component, but there are two components dealing with physical health. It seems basically that this component which should have been one is actually divided into two. So in such situations, what do we do? Should we go ahead with two components or should we combine them? So combining such components is also an option at the end of principal component analysis. Because after principal component analysis, we also have a confirmatory factor analysis step. So if we combine two components and form one component out of them, at the confirmatory factor analysis step, we can see whether what we did is acceptable or not. So therefore, if certain components seem to be divided into 2 or 3, or sometimes that you feel that they would be better if they are connected together, then combining the components and forming one out of them is also an option. So naming the component, important thing is to look for what is common in them, and in combining the components, we can combine and form one component and check during the confirmatory factor analysis whether the decision that we took to combine these two are actually correct or not, so that we can decide at the CFA step. Then another question or decision that we have to make is when you rotate, what method of rotation should we use? So rotation is to make the factor structure more interpretable. So once we run the principal component analysis, the initial solution, sometimes we will not see that the items are loading strongly onto one component. So in rotation, our purpose is to do a further analysis using what is called rotation to make sure that the items are loading strongly onto one factor, right? And not reduce the double loadings and non-loading items as much as possible. Right? So rotation will help us to work out our factor solution in that way. So there are two basic types of rotation, orthogonal rotation and oblique, right? There are different types under these, right? So orthogonal rotation we would go for when the factors or the components are unlikely to be correlated with each other. Oblique rotation when the factors are likely to have correlations between each other. So if there are correlations, we go for oblique rotation. Right? This is, I'm talking about the factors or the components, right? Are the components likely to be correlated with each other? For example, a quality of life instrument, you have three factors, physical, mental, and social, which are likely to be correlated with each other because we know that different aspects of health are related with each other. So in such an instrument, oblique rotation would be more suitable than orthogonal rotation. Then few questions related to confirmatory factor analysis. So there were several questions about fit indexes. How many fit indexes should be acceptable in order to say that the solution is confirmed? Right? Or are there important fit indexes out of these that we should that should be acceptable in order to come to a decision? So there are several questions. So fit indices basically are of three types, right? The absolute fit indices, parsimony fit indices, and incremental fit indices. So our chi-square goodness of fit, then the SRMR and the goodness of fit index are absolute fit indexes. Then RMSEA is a parsimony fit index, and then there are several incremental fit indexes like comparative fit index, non-normed fit index, likewise. So usually the most important index here is the chi-square. Chi-square being non-significant is the most important criteria, or if that criterion is there, we don't need to worry about other indices, right? But in practicality, what we see is we don't see non-significant chi-square most of the time. We conduct CFA, but we see that the chi-square remains to be significant or close to significant rather than being a clear-cut non-significant situation. So then we have to make use of the other indexes to see whether our factor solution is acceptable or not. Right? So out of the other indexes, there is no, what literature says is there is no important index as such more than the others, but most literature recommends at least one category of one index from each category should be acceptable. So in that case, RMSEA becomes an important index, and we usually try to get the RMSEA as less as possible so that we can call the factor solution as acceptable. So, and then if you have few indexes from the other categories also within the acceptable range, then you can make a case to say that this factor solution is acceptable. So if it is not so, like let's say all the indices are sort of falling short of the acceptable range, then what do we do? So the options are actually to try out a different factor structure. Now here comes what we mentioned previously. If we combined two components and made one component, right? And if that factor structure is not really fitting the data, it is not confirmed in our confirmatory factor analysis, then maybe it is time to go back to the original factors, separate them out and try that and see whether that is fitting, right? So trying out different alternative factor structures, probably by combining or separating out the factors, that components that we identified in the principal component analysis. That is one option. And also we need to check the literature. So in literature, this type of instruments, what sort of factors have been there, right? If it is already validated instrument in other settings, what sort of factor structure has it shown? And it might be an option to try out those factor structures and see whether they fit the data better. So trying out different factor structures is one option that we have. If all our indices are falling short of the satisfactory level. Then the other option we have is we can modify the factor structure that we used and see whether the fit indexes are going to improve. So what are the modifications that we can use? So most of these factor analysis software like Literal, they would give you recommendations. If this change is done, the fit indices will improve. So several suggestions are given to improve the fit indexes. But of course, the software will give us recommendations statistically, considering only the statistical significance or improving the fit index, right? But the instrument belongs to us. We have developed it and we have the sense about the items in the instrument. So therefore, we don't need to accept all the changes suggested by the software. So out of those changes, which are theoretically possible only and which you can explain on theoretically only, you should implement and see. Now, for example, the software may suggest that a particular item, make it double loaded, right? So you load it into another factor other than its original factor, right? So when you, before doing that, we have to go through this item carefully and see, is there any reason for someone to, consider this item as belonging to that particular latent variable rather than the first one? Right? Can someone interpret it in a different way? Is there a sort of ambiguity in this item so that different people can interpret it in different ways? So we have to look at the items carefully, and if only it is possible, that we should accept those changes to the factor structure. So let's say we did such changes, and once the cross-loadings were added, our fit indexes improved. So that means certain items are now cross-loading. They don't belong to one factor, but they belong to maybe two factors. So what to do with such items in a newly developed study instrument? So the best thing we can do, those items, we are not very sure where they belong to. They belong to maybe one latent factor or the other. So in our factor structure, the main question is we don't know where to include them. And also they are loading onto two factors because there is some ambiguity in these items. So keeping an ambiguous item in the questionnaire is not a very good decision. So it is better or best to remove such ambiguous items and run the confirmatory factor analysis again and see whether your fit indexes will improve. So these are some of the small changes that we can do to the original factor structure to see whether it can be improved to an acceptable level, and we can confirm that, right? So we can try out these methods, and also we can try out different factor structures if our factor structure does not fit to the data in the very first instance. So if the model does not fit, these are the options we have. Possible modifications, add new factor loadings, and also you can add error covariances. That is, there is some common error between these items, right? So you can add error covariances between items. And but remember, they should be adapted only if they are compatible with the concept. So confirmatory factor analysis, you will not get a solution at the very first instance itself. So don't be discouraged if you don't confirm your factor structure immediately following CFA. It may be a bit of a long process where you have to revise your tool several times, revise your factor structure few times, and then only you may come with the acceptable solution. So model fit may not be achieved at the very first instant. That is not a reason to get discouraged about the new tool that you developed. And also, we need to remember, in practicality, when we run the confirmatory factor analysis, what we usually do is we don't run one factor structure only, not only one model, but we would go for 2 or 3 models, right? So let's say the most commonly, the model that came out of the principal component analysis, right? So we can run that. And then we can combine certain components in the PCA and form a new factor structure and try that one also. So usually we can maybe run 2 or 3 models at the same time parallelly and see which one shows the best fit to the data. So, and then out of them, you can improve the one that is best fitting. So that would be how the CFA would go in a practical situation. So these are the questions that we extracted from the initial ones that we got from you initially, right? Are there any other questions that you would want answers? Or if there are any, I think Dr. Tatsara can bring them to our notice, or you can use the chat box, right? To type in any questions if you don't feel like talking and asking, that's fine. Any questions, anything that you would like to clarify further?
Madam, we already have a question in the chat box.
Yes.
The question is, can we use factor analysis, that is both exploratory and confirmatory factor analysis, where the questions have mixed type of responses, both the Likert scale with 5 options and dichotomous, that is yes/no type in one questionnaire. So they want to know whether we can, I think we have already answered, better to clarify, Madam.
Yes. If there are dichotomous responses, what would happen is that those dichotomous items will not correlate well with the others. So then your correlation matrix is likely to be problematic. So if you have dichotomous responses, which which you cannot convert into a Likert scale, there are instances where that happens, right? There are certain questions, we can't ask them in a Likert scale. They have yes, no answers. So in such a situation, the option we can do is if there are, let's say, few questions dichotomous. So get them out of this questionnaire, get them out of the tool and make those questions a sort of a mandatory component. So that is a separate component which you will anyway have in the tool, and the ones which are in Likert scale, you can get it to undergo factor analysis. And then your factors, component identification, all those will be used only for the data that is factorable, the ones where you have the Likert scale responses, right? And you finalize your tool, and then at the end, you can add your dichotomous section to the tool, right? Because obviously, it cannot undergo factor analysis. So no point in trying to do that. But these questions are also important. That is why they are there. So you can add it as another additional component to the tool at the very end. So that would be a better option than to, try to try to perform factor analysis using dichotomous responses. Most of the time, it will not work.
Okay, madam. Thank you, madam. And we have another question, madam, in the chat, and also similar one in the earlier one. So they want to know, are there different ways of performing confirmatory factor analysis based on the normality of data? And the earlier question that we have was, if the data is not normally distributed, what are the options that you have?
Very true. Yes, thank you, Tansara. Yeah. Yes, there is for confirmatory factor analysis, in addition to the assumptions that we mentioned, normality is the assumption for the usual confirmatory factor analysis that we do using the method called maximum likelihood estimation. So for that, we need the data to be normally distributed. So we can go through, do our histograms and maybe check the skewness and kurtosis and all that, and make sure that the data is normally distributed. Then we can do the confirmatory factor analysis the usual way, maximum likelihood method. But let's say our data is not normally distributed, especially some of these psychometric type variables, they are not normally distributed because most of the people tend to give a middle, maybe a sort of extreme answer sometimes, right? Or everybody agrees or whatever. Then the data is grossly non-normal, we can't go for the maximum likelihood method, but there are other options available. So then, for example, Israel gives a robust maximum likelihood estimation method. So there are the steps, the analysis steps are slightly different, but at the end, what you are doing is again checking the factor structure, whether it fits the data based on the fit indices. So if your data is non-normal, then you will have to sort of study a little bit further and follow the steps of different analysis, probably robust maximum likelihood analysis or such similar option for the confirmatory factor analysis. So there are options even if the data is not normally distributed.
Thank you, madam. And one final question. If an item is deleted during the confirmatory factor analysis, and if a component is left with only 2 items, is it all right to be kept?
Yes, if a component is kept with just 2 items, well, not a very good component, right? But if with that factor structure, if it is sort of fitting the data, if the model is fitting with that data, now this is what you got through the principal component analysis probably, and then in the confirmatory factor analysis, okay, 1 item got deleted and your remaining 2 items, and with that structure, the model can be confirmed. So then I would say the best thing would be to go ahead with that, because that is what came out of the statistics, right? And also, if you have followed the scientific steps correctly, then ending up with a 2-item component is acceptable, because probably in your item development process, you have developed less items for that particular aspect that you're assessing. So that is why you ended up with only 2 items. So I think if the process was followed correctly, it is okay to go ahead with the 2 items, as long as your other statistics have all shown that the model is acceptable.
Thank you, madam. And one final question to sum up. If the factor structure is unidirectional according to the literature, for a new tool, is it okay to do the factor analysis?
Unidirectional.
Yes.
Okay, right. So good question. I have also never thought of it. Yes, if it is unidirectional, is it necessary to do the factor analysis? It depends on whether you want to show that this is a unidirectional tool or a unidirectional construct. So if it is important to show that there is this is unidirectional, then better to go ahead and show that this is there's only one dimension there. But if it does not matter, I mean, it all depends on whether you want to show something. Now, for instance, if it is unidirectional or a unidimensional tool, and you want to show construct validity by showing that this dimension is corresponding to a particular underlying construct, theoretical construct. So if your need is to show that, then it is okay to go ahead and do the factor analysis and show that this is the construct that is underlying all these items, and this is compatible with the theoretical construct. Therefore, there is some construct validity. So if your purpose is that, you can go ahead and do the factor analysis in such an instant. But if not, if it is unidirectional and you don't really have a need to show and identify the dimensions, then of course you can leave out and not do the factor analysis. So it depends on the in the investigator's need actually.
Madam, a follow-up question on that, madam. If with the new tool, can we see whether there are the other domains as well, madam? So
That
she
means-
wants to know whether there are any other domains involved in that new tool as well through the factor analysis. Maybe I think she's talking about new factors in a tool which is already there.
So we are thinking of a unidimensional tool, or is it on a different one?
Yeah, madam. Same, yeah.
Madam,
Yes.
Madam, if that literature says it's unidirectional, would it be possible to check on a new factor analysis with a new tool?
Yes. Very, yeah. Now let's say literature says this is unidimensional, but can you try a 2-dimensional structure and see whether it fits? That is your question, no?
Yes, madam.
Yes. Okay, it can, because now if literature may show it to be unidimensional, but we are trying this out in a probably a new population. No? So the way people, it's all depends on how the participants are going to perceive this, right? So by looking at this questionnaire, if you find that it may take a 2-factor structure also, then it might be okay to, try out a 2-factor model also and see whether the unidimensional structure fits better or the 2-factor model fits better. So you can actually try that. And there are instances where such in literature, we have seen such instances where in some studies, you see a unidimensional one, but in other validation studies, a two-factor or a two-domain structure has fitted the data better. So it may be in that particular population, that is how it was perceived. So it is okay to try that. You can try such, let's say, other domain structures and see whether they fit the data better than the unidimensional structure.
Thank you, madam.
Thank you very much, madam. So that brings us to the end of the webinar and also the question and answer session. So now, on behalf of the academic subcommittee of the College of the Community Physicians of Sri Lanka, I would like to extend my heartfelt gratitude to Dr. Dulani Samarnayaka for delivering such an insightful and engaging lecture on the factor analysis. And we are sure that your very clear explanations and practical insights have made this very complex topic with both accessible and highly relevant to our work. And we truly appreciate the time and the effort you took in sharing your knowledge with us today. So thank you very much once again, madam, for your valuable contribution to this webinar series and for inspiring the next generations of public health professionals. So, and then
Thank you very
final
much.
reminder to all of you to fill in the link so that you can receive the e-certificate. And that concludes the Young Community Physicians Forum for this week, and hoping to see you next week in another important and useful webinar. I wish you a very good day.